Welcome to Algebra 1. The learning goal for this episode is to learn how to solve a system of linear equations by graphing them and finding where they intersect. First, some necessary vocabulary. A system of linear equations is a set of two or more linear equations that have variables in common. For example, this is a system of linear equations. The solution to a system of linear equations is any ordered pair that satisfies both, or all if there are more than two, of the equations. There are three possible outcomes for a system of linear equations. The lines could intersect in one point, in which case that point is the only solution. The lines could be parallel, in which case there is no solution. Or the lines could be on top of each other. In math, we call that collinear, in which case there are infinitely many solutions. Each point on the line is a solution to the system. Let's look at some examples. We want to solve this system of equations by graphing. We can choose to graph these two lines any way we'd like. We can make a table of values, find the intercepts, or manipulate them into slope-intercept form. For the following examples, I'm going to manipulate them into slope-intercept form just for the practice. I'm not showing the steps here, but briefly, on the first equation, I subtracted x from both sides to get y equals negative x plus 3. On the second equation, I subtracted 5x and then divided by negative 8 to get y equals 5/8 x minus 1/4. Again, you can choose to graph these lines any way you'd like. Then I graph both lines. The first equation is graphed in black, and the second one in red. We can clearly see that these two lines intersect in one point. That point appears to be the point 2, 1. But since our manual graphs are not always extremely accurate, we should check this point. We check it by filling in 2 for x and 1 for y in both equations. Since the point works in both equations, it is a solution of our system. Let's try another example. Again, I choose to get them into slope-intercept form in order to graph them, but you could choose to graph them any way you'd like. Here's the graph. The first equation is again in black, the second in red. Again, they seem to intersect in one point, and that point appears to be the point 3, negative 3. To be sure, I check that point in both equations to make sure that it works. Since it works in both equations, it is a solution to our system. Let's try one more. Again, I choose to get the equations into slope-intercept form. If you do it this way, you should be able to immediately see what's going to happen next. But if you graphed it another way, you wouldn't necessarily notice until you graphed it. So let's look at the graph. Here's the graph. These lines are parallel. Since they are parallel, they never intersect, and therefore there is never a point that solves both equations. Therefore, there is no solution to this system of equations. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step, I'm going to prompt you with the question you should be asking yourself, then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So, for this problem, our first question is, what are we trying to do here? What we're trying to do is solve this system of equations by graphing. Next question is, how do we do that? We need to graph both equations. I chose to get them into slope-intercept form, but you could have chosen a different method of graphing, like making a table or using the x and y intercepts. Now what? Now we actually graph it. What do we do next? We identify the point where the two graphs intersect. In this case, that's the point 2, 4. Now what? Now we check our point in both equations to make sure it works. It does. Therefore, 2, 4 is a solution to our system. Let's try another one. What are we trying to do here? Again, we're trying to solve this system by graphing. So what do we do first? We decide how we want to graph it. I chose slope-intercept, but you could have chosen to make a table of values or use the intercepts. What's the next step? We graph it using whatever method you came up with. Now what? Both equations are on the same line. They are collinear. Therefore, there are infinitely many solutions. Any point on the line is a solution to both equations, and therefore a solution to the system of equations. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now and work out the problem, then press play to check. Here's the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem, and work it out in your notebook, then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to solve a system of linear equations by graphing them and finding where they intersect. We did that by graphing the lines using whatever method we preferred, then seeing where they intersected. We learned that there were 3 possible outcomes: one solution, no solutions, or infinitely many solutions.